Welcome to Archiversity online lectures. In marketing research, we collect data using a questionnaires and we collect information from the respondents related to their demographic profiles as well as their levels of satisfaction or their opinions on our products and services. All this data is in the form of a categorical data. So when you have a categorical data, the required statistical tools are non-parametric tests. In the usage of non-parametric tests, if you wish to compare one variable with the other variable, that is whether there is an association between one categorical variable and other categorical variable, we use chi-square test. So in this lecture, I am going to explain you the concept of a chi-square test of independence, then how to calculate a chi-square test of independence using Microsoft Excel. In Microsoft Excel, there is no direct way to calculate the chi-square test. You need to calculate the observed frequency as well as expected frequency. Based on those two, that is observed frequency and expected frequency, you can calculate the chi-square power value, and using chi-square power value, you can calculate the chi-square distribution value. So based on that, you can make an estimation, or you can test your hypothesis whether the two variables are independent or they are not independent. I will explain this concept with an example. Here is an excerpt of a questionnaire which a chain of retail outlets in Hyderabad conducted a survey among their retail stores. They have a demographic information related to gender, age, education, family size and frequency of visits. On the other hand, there is two questions to seek a respondent's opinion. One is that how helpful are the employees at this store? And the scale items are extremely helpful, very helpful, moderately helpful, slightly helpful and not at all helpful. And this is a second question related to product range. In this lecture, I'll explain you the concept of a chi-square test using this first question, that is how helpful are the employees at this store. So the store intended to know whether the frequency of visits, that is number of times customers visiting their store, and their opinion on helpful nature of employees are similar or not. By knowing this, the store can design a training program to their salespersons so that they will provide good service to the customers. For this purpose, they collected a data and they tabulated the data here. The data is collected from 992 respondents. Now here you can see the variables and the responses. Now as we are saying that we wish to know the frequency relationship between frequency of visit and customers' opinion on helpful nature of employees. We can run a pivot table only on this. We can take all the variables also. However, instead of taking all the variables which are not required for our study, we focus on only these two variables, that is frequency of visit and employee helpful nature. So for this, what we do is first click on the frequency of visit, then employee helpful, then I click the end key and down arrow so that these two variables are selected. Then click insert, then pivot table. Now you can say pivot table. Now we will choose new worksheet, then click OK. So here is our pivot table and pivot table fields. So one is the frequency of visits. This I'll drag to the row labels. Now you can say frequency of visit is 1 to 2 times in a month, 3 to 4 times in a month, 5 to 6 times in a month and 7 to 8 times in a month. Then employee helpful nature in columns. So you have extremely helpful, moderately helpful. Then once again we'll draw the employee helpful to values field. So your pivot table is ready. Now why we are drawing a pivot table is to run a chi-square test. These are the equations that we use. Chi-square test is a summation of observed frequency minus expected frequency whole square upon expected frequency, whereas expected frequency is row total times column total upon a grand total, and your degrees of freedom is number of rows minus 1 times number of columns minus 1. So by using a pivot table, we got the observed frequencies from our questionnaire, all the data that we collected here. From this data and using a pivot table, we got observed frequencies. So as we cannot do any calculations on a pivot table So we copy this one and we'll paste here. Alright, so these are number of visits. So we name this as number of visits, and this is row total, and this one is a column total, and this is your grand total. So you can see that there are 992 observations. Now our questionnaire shows that the items are listed as extremely helpful, very helpful, moderately helpful, slightly helpful, and not at all helpful. Now here it is slightly different, that is extremely helpful. Next should be the very helpful. So moderately helpful was here. Now to bring this one here, click on column L, then right click, then insert. Now a new column is inserted here. Now click on column P where your very helpful variable is there. Simply hold this one and drag to the second row. Now extremely helpful, very helpful, moderately helpful, then it need to be slightly helpful. So click on N where not at all helpful, then drag this to column P, then remove this column. Now they are in order according to the questions. Now we got a observed frequency, and then using this observed frequency we calculate the expected frequency. For that, copy this table and paste here. We name this as observed, and this is expected. Then delete all the values here because we are going to calculate the values. Now how is that we are going to calculate expected frequency is, our expected frequency is row total times column total upon grand total. So here this equals to, your row total is 285. Select this cell times column total. So column total is here. Select this one, then close the bracket, divided by grand total. Grand total is 992. Select this cell and press enter key. So you have got a expected frequency for first cell. Now try to drag this to the second cell. You get an error message. Similarly, try to drag it onto the right side. Here also you get an error message. Why you are getting this error message is, in Excel when you drag the cells, automatically Excel will take the next cell. Just to know, we'll click here and look at the formula and click on the formula here. Now observe here the highlighted cells. So when you drag down, instead of 180, that is K9, Excel considered K10. Here also instead of P9 for the grand total, it considered P10. Row total is okay, but we want the next row total. And similarly, click this one and click on a formula once again, and you observe here. So when you drag it onto the right side, instead of the same column P, it moved to the column Q. So how is it you need to avoid this? In the sense, how to get a right equation or how to instruct Excel in a right way. So for that, what is that we required is the column P should be constant and row 9 should be constant. So here we have a formula here. So first, to make a column P constant, insert a dollar symbol before P. When you insert a dollar symbol before column name or row number, Excel understands that it has to keep this particular column constant. So in this case, we want a column P to be constant for our row totals. Then in column totals, we want row 9 to be constant. So insert dollar in front of a row number. Then grand total, we want this to be constant for all. That means this cell should be constant. To make a particular cell constant, you have to insert a dollar symbol in front of a column name and row number. Then click enter. Now once you have entered the dollar symbols, you can see here we made a column P constant and a row 9 constant, then grand total cell constant. Now you drag to down and drag onto the right. Now you can see the expected frequencies has been calculated. Now just to check whether your expected frequencies are correct or not, your grand total should be equal to the grand total of observed frequency. So here equals to sum, then select all your expected frequencies, then close the bracket, press enter. The grand total is 992. So here also in observed frequency you have a grand total of 992, and in expected frequency also 992. Once you are done with this, then chi-square power value, we say p value. So to get a chi-square power value, you need to use Excel built-in function chi-square distribution, that is equals to chi, then you can use a chi-square test. So these functions which are with the extended with the .dst, .dst, rt, these are available from Excel 2010 onwards. The earlier versions will have these values, that is 2003 or 7. So they will have a chi-square distribution, chi-square inverse, chi-square test. So according to your Excel version, you can choose. From the drop down list, I am selecting chi-square test, making an assumption of an older version of Excel. Double click on this. Then it prompts you to give the inputs for actual range. So your actual range is observed frequencies. Now select your observed frequencies. See that you are not including row total and column total. Then place a comma. Now select expected range. Close the bracket, press enter key. Now you got a chi-square power value, the power value of 0.13. This power value we will check with 0.05 or 5% significance level. If power value is greater than your 0.05 or 5% significance level, we accept null hypothesis. When you accept null hypothesis, this indicates that the individuals who are visiting the store and their opinion on helpful nature of employees are independent. That means each group has different opinion on your employees. So they are not uniform, they are not all agreeing for the helpful nature of your employees. That means there is a variation from one group of visitors to another group of visitors. And then to get your chi-square value, here we got a chi-square power value. Using this power value, we can get a chi-square value. Your chi-square value is this equals to chi, and now click on a chi inverse, that is chi-square inverse. So double click on this. Now the probability is the value that you got here. Next is your degrees of a freedom. So how is that you are going to get a degrees of freedom is the formula is here, that is number of rows minus 1 upon number of columns minus 1. So how many rows we have? 1, 2, 3, 4 rows. So that means 4 minus 1, it is going to be 3. Then how many columns you have? 1, 2, 3, 4, 5. 5 columns. 5 minus 1 is 4. So 3 into 4, that is a 12. So your chi-square value or chi-square table value is 17.52, whereas the probability value is 0.13, and according to the probability value and comparing it with significance level at a 5%, that is 0.05, we are accepting the null hypothesis, saying that the opinion about employees among the visitors are independent, that is each group has different opinion on our employees. So this is how you need to perform the chi-square test and interpret the result. Thank you. Thank you for watching the lecture.